if Acon's interested, they might be thinking about doing another plant.
Okay, want to get started? You want to get started on this?
Yeah.
Basically, I've got a slide presentation just to talk a little bit about filter media, how it's used, how it ages, all of that kind of stuff. This is something I put together for, I did a speech at the University of Portland back in June, and I threw this together for them. So I just want to talk a little bit about the filter media itself, where it's used, why it's used, that kind of thing. Then we can get into the specifics of the issues that you're having. So I'm going to run through this kind of quick. If you have questions, just ask. You all know who we are. We've been working on your filters for getting near 20 years at this point. So we're very familiar with your unique problems that you have. There's a lot of filter plants out there. This plant is a drinking water plant. This is one of MWD's plants, and they have 48 filters, 24 on this side, 24 on that side, that are 2,000 square foot each. That's an 800 million gallon a day treatment plant. The end of this week, we're just finishing up changing all their filter media on that plant. 400 semi-loads coming out and 400 semi-loads going in.
Where's MWD?
This particular plant, Metropolitan Water District, is in the LA basin. They have 5 treatment facilities. This one's in Yorba Linda. This is their Deemer plant. If they run all 5 of their plants wide open, they can produce 3 billion gallons of drinking water a day. I've done all their filter work for the last 15 years. I want to show you just the different types of filters that are out there. These are what are called package plants, and they basically have a mixing chamber, a flock basin, typically tube settlers, and then the filters on the end. This is a drinking water plant for the city of Avenal, and they also have crusher vessels as well. This is a small package plant. It's got its own upflow clarifier and filter. This is in Los Gatos, up in the Santa Cruz Mountains.
What's the size of that?
I don't know what the GPM is on it. It's small. I mean, that filter itself is like 4 foot by 4 foot. So there's all different types. This particular plant is in Granite Bay outside of Sacramento, and these filters are very unique. They have a traveling bridge that travels up and down these filters, and you can see all these individual cells. These are 8 foot by 8 foot cells. There's basically 240 individual filters in this, and this traveling bridge travels up and down and indexes, stops, backwashes one, stops, backwashes one. Traveling bridge filters were big 20 years ago. Their quality hasn't kept up with the rules and regulations. This is Orange Cove out in the valley. They have 2 treatment trains. They have filters here and filters here. 2 completely different style of filters at the same facility. This is Monterey Regional Wastewater Facility in Monterey, or actually Marina. We've done a lot of work for them over the years. This is their tertiary treatment system. They're basically sand and anthracite filters. That system was put in about 12 years ago. It's fairly new for them. They didn't do tertiary treatment for a long time. But they supply a lot more of their tertiary treatment water now for all the growing fields down there, because all the artichoke farms and everything, their wells were to the point where they were getting saltwater intrusion, sucking it in, so they had to stop using them. So Monterey Regional built this facility to take care of that. 2 different ways of cleaning a filter. Surface wash arms. You guys will all recognize this problem. And then the other way to clean filters is air scour. This is a filter that's being air scoured. Basically, it boils it like a hot tub. So you use one or the other. You're either using When we look at filter media beds in a couple of slides, you're going to see the heaviest of the loading in the filter is on the top 6 inches of the media. And the anthracite is the coarse filter, and the sand is the fine filter. There's always twice as much anthracite as there is sand in most cases, because anthracite is half the weight. And sand weighs 100 pounds a cubic foot, anthracite weighs 50. When you backwash a filter to expand that bed, it's going to expand 20 to 30%, okay? In order for it to expand properly and re-stratify itself, you need the same tonnage of each material. So you need 10 tons of anthracite and 10 tons of sand. That's why you always have twice as much anthracite as you do sand. So air scour really is state-of-the-art way to clean filters today, because you basically are boiling it. Like on your filters, you would put an air scour grid right on top of the gravels, and it would boil the sand and anthracite like this, and then the backwash rate would come up and wash all the turbidity out of it. What it does is it eliminates the, on surface wash filters, the critical point is that these surface wash arms are within 2 inches of the media. When they get farther and farther away, they become less effective. If they're 5 or 6 inches from the media, they burn up all their energy trying to get through the water, and they never break off the smudge layer that's going on the top. So, in pressure vessels, you guys obviously don't need to deal too much with pressure vessels. There's just, different types of setups. These are the Shamu filters. I'm getting ready to do those this fall for the second time. We do all the Monterey Bay Aquarium filters, a lot for the aquatic world. SeaWorld, we've done all their work. We did the, in fact, I think I have a picture. That's Monterey Bay Aquarium. That's 3 stories in the basement. When they built that place, they put all the filters in the basement, never thinking you had to do any work on them. I've changed them out 3 times. That's the Mirage in Vegas. They have a dolphin display. Those are all their filters. I've worked at all of these facilities. This is a little treatment facility up in Guerneville. But all of these facilities, this is a treatment facility in Bella Vista outside of Reading. These are 10 by 50 foot pressure vessels. All of these facilities work the same. They've all got gravel, sand, and anthracite in them. Some of them, the newer model ones, don't have the gravels. The newer model ones have the air scour versus the surface wash. That's surface wash inside of a pressure vessel. So let's talk about the bed design, which we were just touching on before. Your gravel layers in the bottom, these are support media, and they're there to act like a diffusing mechanism. So when the backwash comes on, this gravel layer, which starts out 1.5 inch gravel and it goes down to like they call it a torpedo sand, but it's a real fine gravel. This is in there so that when the backwash starts, the water is evenly distributed across the filter so that it comes up evenly. And then your sand and your anthracite, as you can see, 9 inches of sand, 18 inches of anthracite. This gets back to that bed expansion and the coarse filter and the fine filter. The sand is always half the size of the anthracite, and it's the same in the case of your filters. This is just another version of a bed design. This happens to be one that has plastic block under drains. The city of Vallejo uses this. We've been working on their filters. This thing has what's called an hourglass gravel bed design. It's got 7 2-inch layers. When you layer these things, like in your filters, some of you got a chance to watch when we were putting these gravel beds in. These gravel beds have to be perfectly level within 1/4 of an inch all the way across these filters. When you're doing 7 layers of 2-inch different sized gravels, it's quite a challenge to bed these things. But they use this because their air scour system is in the block. And they use this hourglass bed design so that they come through the gravels with the air scour. It starts out like 3/4 by half, half by quarter, 1/4 by 8. Then it goes 1/4 by 8, half by quarter, 3/4 by half. It's an hourglass. And it was originally designed by Leopold, who makes the underdrain, and supposedly it was so the gravels didn't migrate and move. And it doesn't work. In this case, those gravels always migrate and move. But there's literally hundreds and hundreds of them out there. There's two types of filter media beds. There's dual media beds, which is sand, anthracite, and then the support media, which is the gravels. And then there's tri-media beds, which is gravels, garnet, sand, and anthracite. Garnet was initially used, many years ago it was put in a filter to help hold the gravel beds in place, to keep them from migrating and moving. Sand weighs 100 pounds a cubic foot, sand weighs 100 pounds a cubic foot, gravel weighs 100 pounds a cubic foot. Garnet weighs 155 pounds a cubic foot, very heavy. Specific gravity of 4.2 versus sand and gravel is 2.6. So they put a garnet gravel in, then they put a garnet sand in there to help keep the gravel beds in place. And you do get some polishing aspects from garnet as a mineral. But the tri-media beds have kind of fallen by the wayside in the last 10 or so years. Very expensive, and it doesn't stay in the filter very long because you're putting something here that's twice as heavy as this is. So, you know, as you're backwashing this garnet is slowly moving its way to the bottom of the filter, and eventually it's gone. And it's a very expensive product. That's a pressure vessel. This happens to be a green sand filter for iron manganese removal. Green sand, one of the greatest things for iron and manganese removal. You charge green sand with either chlorine or potassium permanganate. The green sand filters, there's always more sand than anthracite. They just put a little anthracite on top as a coarse filter. And green sand has to be continually recharged. It's so expensive. There's one company in the entire United States that makes green sand, and they know that. So green sand is, you know, anthracite costs you 20 bucks a cubic foot. Green sand costs you 85 bucks a cubic foot. But it works extremely well for iron manganese removal. So pressure vessels, again, they're all bedded pretty much the same, gradation gravels, sand, anthracite. I'm just kind of trying to give you an overview of different filters. This is a sieve analysis. And, you know, one of the things we're pushing for San Jose to do is a filter surveillance. This is the filter surveillance from 4 years ago?
Yeah, 2008.
What's that?
2008.
Yeah, 2008. So those are 4 years ago. Most of our customers do a filter surveillance every year. Some of them do them every other year. If your media is fairly new, you can do them every other year. You want to watch them age, and you want to keep up with those media levels, especially with surface wash. So what we're looking for in the filter surveillance is we're looking for a couple of things. We're checking to see how the bed dirties up. We're using flock retention test, and we're checking to see how it cleans up. The other thing that we're doing is we're watching the media age. Sand and anthracite age and wear totally opposite of each other. Anthracite, as it ages, this is the effective size of this product when it was new, with an effective size of 1.0 to 1.3, a uniform coefficient or UC of 1.5. Anthracite, as it ages, the effective size goes down because when the particles rub together, they fracture and break, so they get smaller. And then the uniform coefficient goes up because less particles are uniform in size. When this product is manufactured new, it's done to a very specific size. Like, I think yours is a 125 to 135 millimeter, and it's got a 1.4 UC, very high quality product. A 1.1 UC would mean every particle is exactly the same, and you can't manufacture to that tight of a spec. So as these things age, they rub together, so the anthracite's getting smaller, the effective size will go down, the UC will go up because less particles are uniform in size. The other thing that's happening to this anthracite, it's getting lighter. And I take that back to the 10 tons of sand, the 10 tons of anthracite. As they're aging, they get those ratios go off even farther. This is the sand from the same plant. This was a 50 to 60 millimeter sand with a 1.5 UC. It's up to a 7.0 in size, and the UC is down to a 1.3. As sand rubs together, first of all, sand wears faster because it's twice as heavy as anthracite. So when it's banging together during a backwash, it does more damage. And once it gets all the sharp corners knocked off of it, it'll become round like a marble. And then it can't shed debris, and it'll get bigger because it'll get a mineral buildup on it that it can't get rid of. So anthracite's getting smaller and lighter, sand's getting bigger and heavier, and then the bed it doesn't expand right, it doesn't re-stratify right. So it's critical to watch these things age. And that's kind of where a filter surveillance report comes in, to watch that age. And that's why, like backwashing, the only thing that wears out filter media is backwashing. If you've ever heard of a slow sand filter, they're huge. They're like 3 acres big. They put filter sand in it, and they put water in the top and just let it seep through it. They never backwash it. The sand never wears out. But you do have to go in and scrape that smudge layer off the top, which you lose sand and then you replenish it. So it's the age-old problem of, you know, the more you backwash, the more it wears, the more it wears, the more you have to backwash. And you kind of will get into a snowball effect with these filters.
So you do, to establish the uniformity quotient on all these ranges with our existing media, you do some
Yeah, if you look at
standard.
this, right, you look at this report, those exact reports are in here, the exact sieve analysis. And that's like a remaining life report. So, on your filters, and I know Jose is very familiar with these, and he does wonders keeping these things going with all the issues that are going on. I think we need to do the filter surveillance, figure out your baseline, where you're at, because we haven't done one since the media was changed. And then figure out where those are at, get them topped off so we get them back up to that surface wash level. But I've been in this business for 35 years, and the one thing that I think this plant needs to keep these filters going is that air scour system you saw in the beginning of this. I think that will, if you air scour, here's where your savings are associated. You get rid of the surface wash, so you save all the water and energy for running that surface wash. The backwash actually becomes shorter because when you boil it like a hot tub, let me just get back to where we were. When you boil this thing like this, it really breaks everything up, okay, so that you're getting all the debris off of the media and it gets backwashed out. So you don't have to backwash as long. Your backwash rate you still need to expand that bed 20%, but in most cases with air scour, your backwash times are about half of what they are with surface wash. So that's, I think, where these filters of yours eventually need to go. The important thing right now is we need to figure out where they're at today and what we can do to help them today. But the next step for San Jose is going to be put an air scour grid in one of these filters and test it and see the improvements that you'll get. My guess is in a water and energy savings alone would pay to put air scour in these filters.
So in the same token, from your explanation, would air scouring accelerate the aging if it is more efficient?
It doesn't. It's more efficient, so you don't backwash it as long, and it doesn't. The media doesn't cling together any harder. It's just a different concept of the way that it's cleaned. So surface wash on the top takes care of that top 6 inches. This starts like for you, the air scour grid would go right on top of the gravels, and it would air scour the sand and the anthracite. You still have your support media for your backwash water, that type of thing.
Do you have air bubble binding problem when they bind to the media so that it restricts the water flow?
No.
No.
No. Every plant, even, we have pressure vessels with air scour in them. But almost every plant built in the last 10 years is an air scour system. That is state of the art today. And the air scour, as the backwash comes up, as the backwash goes from a low rate to a high rate, when it gets up to a certain point, the air scour just shuts down. And then during the backwash, while it's backwashing the turbidity out of it, the air comes right out of the filter medium because the bed's already expanded. So that's what I was asked to come and, speak and kind of give you guys a little history on media and how it's used and how it wears and that kind of thing. So that's what I wanted to get done today. And
so can you just give us like just in a bullet form or just what you say? Okay, you are going to establish a baseline for the characteristics of the media.
yes,
That's one component of the sentence.
yes.
What else you look into?
The other things that we're looking for are, we do a sieve analysis on the media. We do what's called a flock retention test. And what this is, these are NTUs, and this is the filter media. So we're testing the media to see, every 6 inches we're pulling samples and doing a flock retention test on it to see how dirty the media is. So it shows us the heaviest of the loadings in the top part of the anthracite, goes down into the sand, and then how well it cleans up. So this really tells us how the filters are dirtying up and how they're cleaning up, if they're where you want them to be. The other test we do is a turbidity test. And what this is, these are NTUs and these are minutes. So when the filter goes into a backwash, right when the dirty water starts flowing over the weirs, we're grabbing samples every 30 seconds. And we graph that out. It should start out dirty, and it should get cleaner and cleaner and cleaner, okay? So what you look for here is you look if it's flatlining, then you're backwashing too long because you're not getting the filter any cleaner. Or if it just abruptly stops, then maybe you're not backwashing long enough, and it'll give us that information. The other thing that we do, I don't think it's in this report. The other thing that we do is we map the gravel beds. And we do this because what we're looking for is we're looking for migration of the gravels. Because when these gravels start to migrate, you've got, I want to say 12 or 14 inches of gravel in those filters. And again, as I mentioned early on, those things are, when they're put in, they're layered within 1/4 of an inch of each other. So they're very flat, very specific layers. Starts out large at the bottom and goes all the way to a small at the top to hold the sand and the anthracite above it. So over time, as filters age, when you're go to one of these bed designs. As filters age, as the anthracite is aging, it's fracturing and breaking, so it's getting smaller, and those particles get washed out over the weirs. So you'll always see anthracite in your backwash basin, but you typically won't see sand. Sand, as it ages, as they rub together, those sharp corners that get knocked off of it go down into the gravel beds. So what happens is, over time, these gravel beds are getting impacted with that fine sand that's coming off of the media as it wears. So what will happen is you'll start to get migration of the gravel beds. So if you've got a gravel bed that's 12 inches deep and it starts to migrate or move, then you're going to get, water's always going to take the path of least resistance. So if you've got a 4-inch divot, now you've only got 8 inches of gravel here, you got 14 inches of gravel over here. What happens is when the backwash comes on, it has a tendency to keep pushing that gravel apart because it's stronger where there's less gravel. And that's what we look for in the gravel beds.
And you'll find a lot of my filters like that.
Yeah, this plant has always had problems with gravel migration.
So I already have sand going out the effluent.
Okay.
Because I check my head loss meters and it's tapped into
And you're getting sand in
Yeah, and
those?
you pull off the white strainer, it's packed with sand.
Yeah.
So, what is the reason for gravel migration? What is the reason for the gravel migration?
Well, the gravel,
The backwash not uniformly coming out, or?
you know, if you get air in the backwash, air is probably the biggest thing that affects gravel beds. Or just as the media ages, you're getting that sand into those gravel beds, which is impacting them. And both of those things will cause the gravel beds to migrate.
But we used to have a big problem with air in the backwash system.
That was something you guys worked on for years to get the air out
And
of
it was because the check valves weren't working properly, so it was emptying out the line. And then we start a backwash, so now you got all this volume of air going through, and it would bubble up the filters.
You're talking about the air water system. What's the typical application rate for the air in the air water system? How much
Air scouring?
The air scouring?
Yeah.
It depends on, normally it's around 2 CFM per square foot, something like that, 2 to 3. That's kind of an industry standard with it. And it doesn't matter if it's in the under drain or if it's between the gravels and the sand. That's kind of an industry standard for it. And you know, there's been a lot of people that have done higher and lower, and it doesn't seem to change much.
What's the pressure requirement?
I think it's about 6 psi, 5 to 6 psi. So it's not a high psi. It's not like you need an air compressor. You typically would use a blower, which is a positive displacement pump. That moves a lot of air at somewhere. Those pumps typically will run about as high as 15 psi. So,
I mean, the pressure just enough to drink the depth of the water, right? That's all you need.
that's all you need is to get through that. Right. Right. Yeah. So you don't need a lot of pressure. You just need enough to get through the system, the piping system, and everything.
At what point do we replace them, or you would say, hey, this media is shot, let's just take everything out, put new media and whatever.
Typically when it gets about 10 points out of spec. If you've got a 6.5 to 7.5 sand, when that sand gets up to like an 8.5 because it's going to get bigger, it's pretty much life is gone. Anthracite, it's the same way. If you've got a 1.0 to 1.1 millimeter and you're down to a 9.0, it's pretty much spent.
And the surveillance that you're going to do would tell us about that as well?
Absolutely. Every filter will get tested, and there'll be a sieve analysis on every cell. When we do a filter surveillance here, we treat them like 32 filters. So that, because the other thing that we're looking for when we're doing this is problems. You know, when the guys are probing a filter, like when they're probing for the gravel beds, when they're coring the filter, if the filter's mudded up for some reason, we're going to catch it. It really kind of gives you the heartbeat of what's going on with the filter.
And when you replace the media, the sand and gravel also has to be replaced.
Yes, you have to keep the age, and you always replace the gravels, and the reason is the gravels is the least expensive thing in the filter, and there's always going to be turbidity buildup in them, always. From the sand going down into them, that kind of thing, they're never going to be clean. So if you're going to go in to replace sand and anthracite, place the gravels, clean the under drains, and rebed the thing from the ground up. Because in reality, it brings them back to like new condition when you repack a filter.
I think that eventually, I don't know, there was some talk about, are you guys doing a pilot on disc filters soon, besides? Yeah. You talk about the disc filters, so.
Well, okay, I think that's totally a different set of emerging technologies which we are now planning to do some piloting. But these are with the conventional, media filters. That's something else. But I think what I was just trying to get from this and for everybody's benefit, the reason why we invite you is really now you just list down what tests you are going to do, and you highlighted what are the outcomes of this surveillance. That's really very important that everybody is clear what we expect out of this surveillance.
Right.
You just clearly told us that, well, I'm going to just tell you how all the specifications of the media features are from the state. So if that require total replacement, and if it requires a replacement, it will get in a hierarchy manner. And then you just told us the media migration, especially the sun migration to the ground, which is a really very critical problem. And from practical problem, we is now seeing some filter effluent, some presence of the sun.
Right.
So that's a real problem, and that's also what we want to look as an outcome of this surveillance. The other issue which I would like to bring to your attention, and we have been almost like clearly discussing with Jose, and Jose will elaborate on that, is the mudboarding. Mudboarding and channelization in some cells, not in all. But and the other thing is he has an experience that even the total media replacement, which he did in 2010, am I right? Yeah. Now he's more or less, in the very beginning they were okay, but after a certain time, they are more or less performance-wise like those which are not totally replaced. So I'm just trying to get your viewpoint. I mean, what has gone wrong? Why this total replacement has not really even, helped us in coping up with the problem for a very long period of time? I mean, 2 years duration for such a big media replacement, and still they are performing more or less the same. So if you could just comment on that, and mudboarding, channelization, and if you happen to determine that media migration works, is your recommendation to come up with totally different type of sand, or what's going to be your recommendation for?
Well, when the size of the sand and the anthracite that you have was determined by testing a lot of media. We worked with Simong for about 3 years. I mean, this is back in the late 90s, early 2000s, to determine the best media. So that media wasn't just picked. We tested all different sizes and combinations of media. So that's what it was designed for. If the mudding is still going on, the filters aren't cleaning themselves. So we have to determine why they're not cleaning themselves. If it's that the media is too low from the surface wash, if it's Jose's playing with some backwash rates and things like that, which is a great thing to do, okay? It may be that we need to clean them from a different direction, which would mean air scour to get them, The media, I don't see any reason that the media shouldn't still be in good shape in these things, okay? We have to figure out how to keep it cleaner, okay? So part of this surveillance is like the flock retention test. That tells us how they're dirtying up and how they're cleaning up. So those are the kind of things that we need to look at. We need to look at the media levels and see how far they are from the surface wash. The surface wash times and the pressures in that of the surface wash, I mean, you're playing with them a little bit now, but the pressures and the flows have stayed the same, right? On the surface wash. And from what I've seen with the surface wash, when it's working, it's very effective. So these are all the things, the flock retention test will help us, the turbidity test will help us, those kind of things.
So do you see less mudboarding when you use air scouring versus the
Yes.
surface wash?
Yes, because the filters clean better.
If you use surface wash, the entire backwash.
The only thing about surface wash through the entire backwash is because when the bed's fully expanded, there's two things that it does. One, you've got the surface wash running in the buried media. So from a maintenance standpoint, it's very hard on the surface wash. If you had a fixed grid surface wash, it would help.
But our original design was to have an arm embedded inside the media.
Subsurface surface wash
Yeah,
arms.
so it had both sets, so the pumps and pressure, everything was sized for that. Well, we went ahead and eliminated the bottom because we used totally different material on the arms. We used copper, so it bent a lot easier. Now we're stainless steel, and a lot of my arms have been reinforced by maintenance. So I don't see an issue with them breaking anymore when you have high rate backwash and you have that full bed expansion. We used to run them all the time before we did the rehab. Once we did the rehab, we got these new arms, and then we started having issues with them breaking. So then we just ran the surface wash until we called for the high rate to kick on. Then the surface wash would cut off. So I'm thinking the mudding is because we didn't run those surface wash arms the whole time.
Almost
I think
every,
it could have slowed that down.
I don't know. I mean, a standard surface wash system, the surface wash will come on for 4 minutes by itself and run, and then the backwash will come on, and as the backwash ramps up, when it gets to full rate, then the surface wash should shut off. That's an industry standard of the way that those work. Okay. If you run them through the whole backwash sequence, the one thing you will do is accelerate the media loss a little bit because you're keeping it all stirred up, and as it's flowing out over the weirs, it's carrying more media with it. Okay. So, but
you're also getting a lot more of the mud out too.
well, like the matting that you said was going on in there, if it's taking care of that, then you got to weigh it a little bit. You know, is it worth a little more media loss, you know, to get the mat out of it? In my opinion, it probably is worth a little more media loss. But the critical aspect of this is you've got to top these filters off. All filters lose media. Industry standards, 1 to 2 inches a year. Okay, that surface wash is designed to be 2 inches from the media. So if you're on the high end of a media loss and you're losing 2 inches a year, you in reality should be throwing anthracite in these filters every year, at least every other year, and that will keep your mudding issues down, because the closer the media is, the more effective the surface wash is.
I think we lose more than 2 inches a year. I think at one of the filters, or 1 or 2, were losing 4 inches a year. I don't know where it goes.
So if you top off the media, filter media every year, then you don't need to replace them ever, right?
It doesn't regenerate the bed, Ron. It doesn't. It's, you know, you're just replacing the, you know, what's on the top, but it doesn't regenerate the bed because the basics of the bed are going to stay there. What will happen over time is the media will be bigger on the bottom than it is on the top if you keep topping it off. But it's not like putting new anthracite in it or putting new sand in it. And the other thing you have to keep in mind is about every 4 or 5 inches of anthracite you lose an inch of sand. It's about a 5 to 1 ratio. So you've got to, and again, back to that 10 tons of each product and the weights and keeping that bed expansion right, you do need, and that's what a filter surveillance will do, is if these things need to top off, when we top them off, we'll throw the sand and the anthracite in there, have you backwash it, everything goes back where it belongs. But you can't lose sight of, because you know you're getting a little sand out the bottom already, but you can't lose sight of the fact and just keep throwing anthracite in it. Otherwise, in 10 years, you've got all anthracite and no sand. So you've got to address both issues.
Then you become monomedia, basically.
Yeah. Yeah.
Most probably you could shed us also some light on some of your plan for the logistics. I mean, we are also planning and trying to make some proposal how we can undertake this surveillance. So could you please give us how long will it take this surveillance study from the time you immobilize your equipment or your staff till the end, and what arrangements you like, what assistance from operation and cooperation, I guess.
Basically what happens is a 3-man confined space crew comes out, works with Jose. We want to take the filters when they're dirty, when they're the dirtiest, okay, so like at head loss, and have them drain them. So we typically try to do 2 filters a day, which is 4 cells a day. So take your 2, get them to head loss, drain them, we come in, we core them, we set up a bunch of equipment and have them backwash the filters and then drain them again. And then we set up more, or we do more testing, pull more samples, and that's how we work our way through all of it.
So about 8 days?
About 8 days in the field, probably 3 to 4 weeks in the lab, and then probably a couple weeks at least to put the report together. So we're probably looking at 60 days, somewhere in that range. So,
Is there any time you want to be informed to mobilize your staff and equipment, or how?
whenever you're ready, we're ready.
Okay.
So we have multiple filter surveillance crews. Again, we're right across the street, so there's no travel issues or anything. So, yeah, the field part of it goes by relatively quickly. It's the amount of lab work, because you're looking at thousands and thousands of samples that have to be tested. So
is that the lab work you would organize on your own? And then
we have our own lab.
With us?
yeah, this is a turnkey operation, so we do everything. And then when the report is done, I'll come out, we'll take the reports, and we'll go through them page by page, everything. We'll look at all the data that's there, I'll explain all the data that's there, and then we can talk about recommendations on what to do with it, the next step.
Yeah, it would be generally that's the common practice we do with CIP design and consultancy. Just give us a draft report.
Exactly.
Yeah.
Yeah.
Sounds good. Give the draft one, and then we will pass it around and do your comment, and then most probably when it's about to be finalized into the final one, you come up this one day and just give a presentation.
Yeah.
Will you have, sorry.
What you think of using some sort of porous plate in lieu of the gravel ones?
What kind of plate?
Some sort of porous plate or something like that?
It is, tiles versus stainless steel.
Is there a gravel?
That's the one which we put in before.
The support, the support medium.
That's with monomedia.
Oh, it works good.
The hope was when we put the panels in 4,
It works just as good as the other technology. I don't see anything.
the hope was to put the panels in 4 was that you would put a standard bed design back in it, so we had something to compare it to without the gravels. But there was a decision made to put all anthracite in it. Now there's no data from filter 4 that relates to the rest of the filters. And, you know, this was something that long conversations about, but if you would have put the standard sand and anthracite in filter 4, like you have in the other ones, we would have seen the advantage of getting rid of the gravels. But because you put all anthracite in it, the data doesn't correspond to the other filters at all. So,
And generally, those systems work much better with air scale.
yeah. I truly, I've been at this plant for 20 years doing work, and I truly think the next step is for you to air scour. And it's easy we can test one. I mean, it's something that we were trying to do at the end of our last contract. Just take one of the filters, put a grid, we even wanted to put a grid in 4. And you know, put the grid in there. We can work out the details with the blower and all of that stuff later, But we could have had the grid in there, and we could have tested it if we'd have put sand and anthracite like the other filters. But we could take any one of the filters. When we're done with this filter surveillance, pick the worst filter that you have, the one that's performing the worst. Jose probably knows that off the top of his head. See? And put an air scour grid in. We can slurry out the sand and anthracite without damaging it, so you don't lose any of the media. Put a surface wash grid in, work out a way to put a blower pack on it, and test it. I mean, it's really the future of this plant to get rid of this mudding issue that's going on.
Do you collect those, before the goes through the filter? Do you get a sample to see what kind of, in comparison to the water, sewage water in other plant? Otherwise, how can you compare? Right.
How can we compare? We're just comparing your filters to your filters.
Yeah, I know, but the sample, the source of the water before go through the filter, right? You have to know if you're going to compare to the other plant, right? Then you have to compare what kind of source or quality of the water. Then you can compare the result of the filtering result. You got my point?
You mean what your raw water quality is going on to your filters?
Just before enter the filter, you have to get a sample to see it, because you're going to compare the result with the other plant, right? If a given the raw water, right, then you cannot compare the result to the result, right?
What he's saying is a very valid point. What he's saying is, now we are, regardless of what, our surveillance focuses on the deterioration of the media and things like that, regardless of what is the quality of the influent. So what he's saying is, if the quality of influent for San Jose is such bad compared to another plant whose filter influent quality is much better, and with that filter influent quality, it will impact the filter process. The one which has bad influent quality will be impacted more, and it may require a replacement or whatever more frequently than the other one, which has a better quality. So he's seeing that outside of the filter domain, a little bit upstream. Is there any way you can think of?
We have no control over what comes out of the secondaries. Okay,
you're right, but you have to compare first what kind of raw source of the sewage, right? What the turbidity, and then you compare first, right? Then later you compare the result. Otherwise, you don't know different plant, different quality of the raw water, right, going through. Then how can you compare the result?
Well, every plant's secondary water going to their tertiary treatment is different.
Exactly.
It's different.
This is the point I want to
And there's some
emphasize.
plants that have filters just like yours, dual media filters, that backwash them every 2 days. Okay?
That's the key point what I said, because every treatment, the processing, right, the procedure all different.
Right.
So you have to get a sample right before entering filter.
That's the
You
job.
have-
That's the job of the plants,
That's-
not these guys.
Yeah, because we're
But
dealing with.
however, you have to know, right?
Well,
Then
that's our
later
problem.
you can compare result to result.
Yeah, that's our problem.
Yeah. No, this is
No,
not
this
a
is
problem.
true. Yeah, this is
You
true.
have to get it right, compare the quality
I know, but
different.
that's something we have to do, not.
But
But
the-
our
with our
quality-
effluent, yeah, from secondary is, it's 8.5, no way, man. You're not gonna get 10 hours
There
out
was-
of that. It's
there
just,
was-
it's
Well, yeah,
just not
and-
gonna
and-
happen,
and-
so.
and that's-
There's something else, there's other problems than just the influent. If you were at 14, 15, 20, something like that, then I could see maybe.
There has been
major
some
problems.
sort of.
And it changes. It changes.
so-
We can have a clarifier puke, and now you got,
Yeah.
So suppose you are going to compare the plant, Sunnyvale, for example, you have to guess exactly
But I
the
don't
the
compare.
filtering medium, what kind of sand, right? How deep a layer, the gravel, and you have to actually be the same. Then later on you can compare. Otherwise, different source, right, and the different media, then the result
But
would be.
I'm not comparing your stuff to anybody else's stuff.
No.
We're worried
not
about your
competition.
filters.
We are not talking about competition. our system should be better. No, then you compare two systems. The media, in a future media, and then that everything, including the source of the sample before, right, going to the field, everything should be, not a, sewage cannot be exactly the same, but should be some kind of a, similarity, or even different to get a ratio, then later on result also get a discount, the ratio, everything, then this is, comparison will be more reality. That is my point, because every treatment, the water process is different.
Yeah,
Yeah.
and
That's my key
every
point.
treatment plant is different. Every
I know,
treatment plant-
that's no argument, right?
Yeah, I mean, there's
Yeah.
no two of them alike.
Yes,
I
exactly.
think you are right, Jim. I think it's a very valid point, and definitely, as Mary said, I think we will have to look at, but it's just a little bit out of the scope of this
Yes.
work.
We're
And the point-
concentrating on
The
the
point
filters.
is very valid.
Yeah.
Yeah, I
The point
mean,
is very valid.
the filters will run 2 days if your effluent quality is 2,
Let's change secondary.
you know?
Fix that.
Obviously, that's the
Yeah,
biggest
whatever
effect.
BNR does, it'll fix it.
We have to.
Well, you're on the tail end of the system, so whatever goes on upstream, it affects you drastically.
Yeah.
So
So,
will you have
We're not
a
sure where they're
recommendation
second
section in your report?
Yes.
After your future seminars, will you include the recommendation?
yeah, once we go through the report, then we'll talk about, what the recommendations are, and then we'll put something together for that. Okay?
Yeah.
We keep these things separately.
Separate, that's
This
why
is
I don't
engineering
say
data,
anything in there.
okay? This is technical engineering data.
Yeah.
We're gonna talk about this on its own. Then when we talk about recommendations and topping off, or whatever it may be, then that's a different
Oh, yeah.
process. I don't intermix these two, okay? Because this is technical data only. It's unbiased. What it is what it is. What the data comes out to be is what it is. Then we'll talk about recommendations.
Well, which
Oh, yeah.
means in this project, recommendation is not part of it.
No. It is
No,
part
we'll
of
make
it.
a
We'll make
recommendation
part of it,
once
but
we
it
go
will be as
through the
second
report.
part of the report. Second part of the
When
report.
we sit down and I walk you through this report page by page,
Okay.
which is going to take hours and hours and hours, but you'll understand exactly what you have and what the filters are doing now.
Okay.
Then we're going to talk about, well, these filters need this and these filters need that, then we'll put something together for that, a recommendation for that. But we always keep the filter surveillance separate, okay, because you don't want to intermix the two, because this is unbiased technical data.
Yeah, I think I agree with you, and it should be combined in such a way that first part of this soil surveillance is the technical data, and then the second part is the recommendation.
Exactly, and that's the way that we
Yeah.
deal with it. We're going to do this, we're going to review this, everybody's going to understand this report. Then we'll collectively decide, talk about recommendations, this is what we need to do, then I'll give you a proposal for that. But they're two separate issues, because this is just unbiased data.
That's still part of this project, right? Not another project, another budget.
No,
No.
no,
Okay.
this,
Okay.
no.
And what for then we are doing the surveillance?
Well, I got to get my money back for the lunch, Rob.
No, it's good that you raised it, but obviously,
Yeah, for the
we need
snacks.
to get a document that guides our intervention.
I'll have to call you next time, Tom.
Yeah,
Tell you
thanks,
real
man.
food, okay?
Thanks, bro. Appreciate it.
I have a simple question for you. Today, nowadays, right, contamination, right, from the seashore, even the river. So when we buy the sand, right, gravel, do you know what kind of treatment before they sell it to us? Because otherwise, right, especially later on, the recycled water, right, even we talk about the potable water using the recycle. So what I'm saying is that those sand we're going to purchase from gravel, do you know how they doing the cleaning process?
Absolutely. I know
About
everything
the-
about our
okay.
filter media. The filter media that we use in this facility
Yeah.
is the high, all of our filter media is the same. Whether it's a drinking water facility, whether it's to take care of Shamu at SeaWorld,
Yes, yes.
or whether it's to work
Yes,
in your
yes,
filters
yes,
here.
yes.
We use the highest quality industry standard filter media
Can you explain a
available.
little bit? Yeah.
We want to make sure that you do not go out to our field and take sand from the back and then sell it to us.
Maybe-
That's our main concern.
Maybe
See, if I was doing that, I wouldn't be doing a filter surveillance report because it'll show up in there.
That's why I asked the question.
No.
You know, maybe.
We use the best products available that meet drinking water quality standards or better.
Yeah, I know. But
You
how
don't
can
get
tell
anything different than.
I understand. You're very repeat.
drinking
I'm not
water.
questioning how do they're doing the cleaning, washing, the processing before deliver to us.
Right.
Do you have some idea?
Well, yeah, it's all, first of all, the materials come from very specific areas. You can't go out here in a sand pile and dig it up,
Yeah,
okay?
good. Yeah, good.
And the sand comes from Monterey. Most of the sand that we get comes from Monterey. And it's washed like 3 or 4 times, then it's sieved and sized. Okay, the gravels are all silica gravels that come from the Marysville area.
Yeah.
And they're washed multiple times and sized, and even the smaller gravels have to be crushed and
Yeah,
sized.
after washing, do
So-
they get a sample to have the lab test any contamination
They have
with chemical?
Yeah, all of these facilities that we use are NSF certified, okay? And they have to hold that NSF certificate in order to make it for drinking water
So
quality.
government also got involved inspections.
They get inspected every year. There's quality standards that they all have to meet.
Oh, okay,
So,
good.
and
Yeah.
all that
And
we
this
use
government
is drinking
get,
water
get
quality
involved
materials.
Doing the inspection, oh, I think good.
And all the sand and anthracite do have C of C and C of A.
Yes.
Certificate of analysis and certificate of conformance.
Yeah.
Good, yeah, good.
Yeah, the uniformity, the effective size uniformity coefficient tells us exactly what the size is, and every truckload of material that goes through our warehouse is tested. Every one that comes in is tested. And I'm talking about thousands of truckloads of material every year. All of our suppliers are held to very stringent standards.
Good.
And before the stuff leaves their facility, it's tested. They gotta send me a test before they can even put it on a truck and ship it to me. When it shows up in my facility, I test it again.
I see.
So it's all tested multiple times.
Okay, thank you, yeah, thank you.
So,
I think one more last question maybe from me is basically your surveillance will lead into a media replacement as an option of remedying the problem. There is other group of doing the same surveillance whose recommendation is not media replacement but rather media rehabilitation. So
yeah, flooring to acid wash it. I'm
Exactly.
well aware of that.
So
But here's the problem. You cannot put the corners back on the sand. You cannot glue the anthracite back together.
So my question is there any media rehabilitation recommendation in yours?
Never.
In favor?
Never.
Why?
Because I don't believe it. I've been in this business my whole life, okay? And sand wears because it rubs together, and when sand is new, you look at it under a microscope, it's very sharp and jagged, and they're all the same size. When sand is wore out, you look at it under a microscope, it looks like marbles. Now, could you acid wash that and make it change a little bit? Yes, but you're never going to put the corners back on it.
So here's the question. If you surveillance a filter, and it turns out that the specs are up to the code, no problems, but you still have modball issues, and no backwashing would resolve the problem. You have 2 options. If you cannot really figure out how to change that modball problem or remedy that, you have 2 options. You take everything out with new media in, or you somehow get rid of that modball by physical or chemical reactions. That's what we are trying to figure out. Because if your specs for media and sand are the same, what difference does it make if you replace it or not replace it? It's the same material, right?
Yeah.
I mean, but you're right. If the material is gone, it's like
You
there is
can't
no
rejuvenate it.
Yeah, there is no way.
I mean, you can get mudding out by hypoing the filters, okay? But there's a reason that these things are mudding up. We gotta figure out what that reason is.
Absolutely.
Once we stop it, okay,
That's it.
they're gonna eventually clean themselves up if we stop the mudding issue, okay?
And this is going to tell us that
This-
where the source of mothballing is.
And you know, the source of mudballing may be, there's an upset in the secondary and you're shooting 20 NTU water over to the filter building. I mean,
That could be.
and once it gets in there, the trick is to get it out, so.
Now, we suspected at some point that maybe there was some sort of, because we use polymers for coagulation, maybe that was the source. I don't know. Maybe that's
Chemicals are extremely hard to get out of filter media, so.
So, I mean, as an extended benefit of this surveillance, you would also give us some idea how our rehab, I mean, how our bathwashing is done, whether it is the right way, of course, they do it the right way, but especially you are now concerned with the top arm.
Right.
second
Immediate
arm,
levels and
second
all those
things
things
like
are
that.
affected.
So you can have some recommendation on the mechanical
Yeah.
aspects.
I mean, if the media is 4 or 6 inches away from all the arms, then they're not working, and that's attributing to the mudding issue, okay? You know, that, what comes out of the secondary, nobody here has any control over, okay? And I'm sure Jose can know within hours of when he gets hit with a slug of something from the secondary, right? I mean, it affects your filters, you know that right away. And, you know, that's the nature of the wastewater treatment business, okay? So those things are hard to deal with. But what we need to do is figure out what's going on with them now, what it's gonna take to get them cleaned up, and so that they don't go back into this condition again.
Now, if we issue that PO within like 2-3 weeks, you can start the work like right after.
I could have a crew out here next week if you wanted to, okay? I mean, we'll respond to you, all right? I mean, from talking to Jose today, the problem is compounding itself at this point. Let's get to the bottom of it before it becomes an issue. And he's working diligently to get these things cleaned up. And but let's get the data so we know what the issues are.
Exactly.
All right. Thank you very much.
Okay?
Good, thank you, yeah.
So